Hey guys, today we're going to do our presentation and presentations details and also the construction's recommendation for like a new mixture use commercial and retail hub commissions by the owners. And the project exists to find some dynamic place and curating to major retails with a focus on effect construction timelines and the use of medium to high quality, low maintenance, and material for optional outcomes. And here is the scope and purpose. First is the total site area is like just 40,000 square meters, and the building's components. First is the west wing size. It's just only like 4,500 square meters, and it's like just a single building with cinema and arcade and also building alley. And second is the east wing side is just like 6,500 square meters, and it's a street-store shopping center with an underground parking and retail spaces. And the rest of them was like 2 stories above ground car park and also outdoor area, which was used for restaurant and lecture areas. And next we are going to like simplify our recommendation about bottom to up construction. And the bottom to up construction will be like, first you should like to prepare the site, and second you should excavate to the first floor, and third you should like add like some temporary support and also more support when the temporary support is done. And next you should like to build a basement, and don't forget to install the columns and the slabs, and finally you can just remove all the supports and build ground floor. Hey guys, then we are like going to do some brief introduction about our retaining system and basement wall system. First, in our basement wall system, we choose skin pile walls rather than contiguous wall because it's more cost effective, and also the waterproof is more stronger, and the durability is also more longer, and the maintenance is like more easier than contiguous wall, and also the quality is more higher too. And these are the summary about a skin pile wall. A skin pile wall is made of like overlapping piles that create strong waterproof barriers. Like it can be reinforced with steel and also add strength. And the process will be like install reinforced piles, and then we will install reinforced piles. And the next we will like consider about the deflection control, and finally will be the retention. And the common use will be like to support excavation or like support wing walls, like kind of things. And here are some case study. First is the case study that we have been in site visit. It's like a project Orama is also using skin pile wall. And next is Korea shopping center is like a 2-story underground park with like 3 or 4 upground like storage shopping center, and it's very similar to our CCE project. It is also located in the east wing in that kind of area. And the basement construction part, I think these two are the deep basement car park and will be faced on challenge with like water management and also soil disability, but the skin pile wall will save all these problems. Okay, then let's focus on basement foundation system, basement waterproofing, dewatering, and also basement floor slabs. Like first, about the foundation system, we use fracking piles and also screw piles. For deep foundation, we use fracking piles, And for like shallow foundation, we use school piles. And the deep foundation part is just only in east wing side only. And next is waterproofing recommendation. We use liquid mobile systems because based on our limit budget and also less maintenance. And next is our deep water recommendation. We choose two. One is well point system and the other is deep well dewatering system. For well point system, we use a shallow foundation part. For deep well dewatering system, we use a deep foundation part. Okay, next focus on basement floor slab. Basement ground slab and basement suspend slab are all slab with membrane system, and the pros will be it will be cost more effective, and also the design will be more flexible. And the cons is like it's limit space and also have some limitation about building service. And the study case we find is a car park in Coral Mill, but it's very similar to CCE project.
Now we are going to talk about the superstructure, which is the floor slab for this project. So our recommendations of this project is on use of the flat slab system combined with the post-tensioning technologies. So this combination has been carefully selected to meet the priorities, so which are streamlined construction timelines, medium to high quality finishes, and low maintenance materials. So the unique challenge of the project is uneven soil conditions and the distinct and functional requirements of the west and east wings. So over the next few minutes, I will explain why this system is the optimal choice, addressing its adaptability, efficiency, and ability to meet both structure and functional demands. So first is the key challenges and the structure demands. So for this project, its purpose for the several distinct challenges, so which are effectively addressed by the flat slab and post-tensioning system. So first, it's about the uneven soil conditions. The site has highly variable soil conditions, so flat slab system distribute loads evenly, reduce stress on the foundations, while the post-tensioning redistributes these loads effectively, minimize the settlement risk. So this combination ensures the long-term stability and reduce the need for closed deep foundation systems. So second is about the functional requirements. The distinct functional of the western and east wings demand the structure solutions. So the western wings houses the open entertainment space like the cinema, bowling alleys. This requires a long uninterpreted spans to increase the flexible layout and enhance user experience. So flat slab paired with the post-tensioning achieve this, minimizing the need for the interior columns. And then in construct, the east wing serves a multi-story shopping center with the additionally load-bearing requirements from the 2 stories underground car park. So post-tensioning flat slab reduce the slab thickness, lightening the load on the deeper foundations while maintaining the structure integrity and accommodating the heavier vertical loads. This approach ensures that the both wings meet their unique specials and functional needs without the compromising design flexibility or structure performance. So third is about efficiency and long-term performance. So we'll emphasize the efficient timelines and low maintenance material further support the choice of the flat slab and post-tensioning system. So the construction efficiency, flat slab simplify the formal process, significant reducing on-site labor and construction timelines. So post-tensioning minimize the material use, cutting costs without the significant quality. So this streamlined process Allergens prefer with the project tight schedule. So second is about durability and maintenance. So post-tensioning enhance the crack resistance, ensure long-term durability. This reduces the need for the ongoing repairs, meeting the developers' requirements for low-maintenance solutions. So together, this system creates a high-performance structure that is both economic during the construction and cost-effective over its lifespan. To summarize why flat slab system and post-tensioning are the best fit to our project, here are the 4 reasons. So first is about adaptability. So the combination of this system effectively addresses the variable soil conditions on the east and west wings of the site. So second is about efficiency. So the optimized material usage reduce the construction complex and also the alternative timelines. Third is about the design flexibility. So this system supports open layout in the west wings and heavier structural loads in the east wings, delivering the solution for both functional zones. Fourth is about the durability. They ensure the long-term performance with the minimum maintenance, achieved with our goals. So in conclusion, in the combination of the flat slab system and post-tensioning technologies provides a comprehensive solution for this mixed-use project by addressing the challenges posed by the uneven soil, device functional requirements, and tight construction structures. So this system ensures the balance between the performance, efficiency, and the cost effectiveness. Now I'm going to talk about the formwork system in our project. So based on our research, the conventional formwork is highly flexible and can be adjusted on site to accommodate to the unique requirements for both the west wing and the east wing. So for the conventional formwork can be repurposed for the different sections, saving both time and resource. Moreover, the construction teams are familiar with the conventional formwork. That will be minimize the errors and ensure the smooth construction process. Based on the research that we did on the PERS, so this building is quite similar to our project. Through the analyzing the case study, we can apply the super short system from the Cassie Foam company. It is particular offers the benefit of the cost efficiency with the improved productivity. So frame spacing can be simply increased or decreased in the design to accommodate different slab thickness. So in conclusion, the conventional formwork was chosen because it adapts to the site structure and the soil variability. It cost efficient and straightforward to use. Also, it supports the sustainable construction practice as well. So when we combine with the flat slab and the post-tensioning, it ensures the comprehensive, efficient, and also the environmental consideration solution for our project as well.
Now I'm going to talk about the facade systems of our project. The first page includes the facade systems, the materials comparisons, and choices. First of all, I would like to say about the certain wall systems and the infill panel systems. The certain wall systems have the faster installation and high quality control than infill panel systems. And the certain wall systems also enhance the thermal performance, but sometimes have a higher cost. The infill panel systems have a long-term installations due to need more labor force, but is suitable for the medium budget project or low-rise buildings. And then I will talk about the facade material selections. The first is about shopping center. It's required a safe, durable materials to draw the customers and enhance the shopping experience. And about the car park, it's about requires a durable and no maintenance, and the weight-take materials to ensure airflows, the weather resistance, and impact protection. So the remaining comparing the 4 materials of the shopping center is about low E, glasses, aluminum composite panels, precast concrete panels, and solid aluminum panels. For the car park, we're mainly comparing about three materials. They are metal lower panel, perforated metal panel, and fiber cement board. So in conclusion, for the east and the west wing, we would like to choose the low E glasses for the sections facing the street and outdoor areas. And we would like to choose the aluminum composite panels, is ACP, to install in other places. For the car park, we would like to choose about the perforate metal panels because of the airflow, and other side is to maybe to have a small usage about metal lower panel. Now I will introduce the facade details of the shopping center. For this project, the aluminum composite panel, which constitutes the largest portion of the building facade. But now I would like to mention that this materials is a fire-resistant materials and installed on the surface of the concrete wall, which means it's suitable for the type C and type B construction. And the first is the materials composition. This kind of materials have a lot of layers. It includes about PVDF color coatings, aluminum schemes, the co-institute, and the fire-resistant core. For this materials production process, the first is cutting and routing and grooving, and then bending it, and you can drilling it and punching it. For the transportation of these materials, the first step is masking it, and then packaging. You can use the protective film, foams, and wooden strips, and then flammable track transport. For this kind of materials installation, it's used the panels are secured to the wall using an aluminum frame system at first, and a low to medium module system and applied to fill the gaps between the panels and ensure the joint movement capable and achieved. The last one is about the maintenance of this kind of materials. It just requires at least a year to clean it. And then we have a case study about the Westfield Chermside Shopping Center. Now I will introduce about the facade details of the car park. The west wing of this project includes the 2 levels above ground car park located near the main display areas. So the perforated metal panels were chosen as this section. The first is about this kind of materials production. And the beginning of the production, the first step is you can choose and selection the materials and design it. And then you can perforating and cutting and shaping it. And the finish, and you can make some surface finishes and control qualities. About this kind of materials information, the first is aluminum, and the max width is about 1,500 millimeters. The open area is near about 15%. So for the transportation of this kind of materials, the first step is packaging and practical, with the elastic wraps or foam sheet for the surface, and use the wooden panels for the movement. And I would like to mention about unloading and delivery. You should be careful for the surface defect. And then about installation. The first step is you have mounting the hardware installations, and then preparation supporting structures, just like the steel or the aluminum. And then you panel the positions and fixation, and you can finish it. For these sections, we have a case start is the Indoor Shopping Center. because these kind of shopping centers have these kind of materials. Thank you.